Here we go. So welcome back, everybody. Today's a review day with one new piece of info. Then tomorrow, another review day. And then the test is Friday is my current plan. Okay. Possible I could change. We were originally going to do it later than that, but I think we'll be ready. If we're not, then I'll adjust. So to start with, adding and subtracting need a common denominator. Add, multiplying, and dividing. There you don't need a common denominator, but you might need a factor. So let's talk about a couple of those. Here's one where it doesn't have a common denominator. So you can't add them until you get a common denominator. Would you please get a common denominator and add those? So whenever you're trying to decide what the denominator should be, you just multiply the denominators together. X times 1 is x, so the denominator should be x. So you should be like, okay, well, that's already an x, so that one's good. Undo the headphones. And then, Jay, have you got headphones in? No. Okay, thank you. Can you tell me what I should multiply this on the right side by? You are quite late, sir. Hurry up, sit down. Okay, what? You want to multiply by the right side there by what? Yes, there you go. Now they have a common denominator. Okay, now everybody add them together. Taylor, the tops get added. How can you add those though? So what do you think the answer is?
I got 3x over 1.
That's a really common mistake. That's like you just said, I'm going to make that have an x on it. Because if you add them together, the only way you could do that is if this had an x. That doesn't have an x. So you have to leave them apart. 2x plus 1. They are not simplifiable. You just leave them as 2x plus 1. Okay? Then on the bottom, it's x. And there's your answer. All right, let's do another one with getting a common denominator. 1 over 3x plus 4. Hint, 4 is over 1. Get a common denominator? Add them together. So there's like, there's a whole bunch of stuff that we need to know by our next test. But there's adding, subtracting, multiplying, and dividing with variables that we have to be good at. By now, I hope this one was pretty easy. You go 3x times 1 is 3x is the common denominator. That's already got that. So this needs a 3x. You can't just multiply the top by it. You have to multiply them both by it. And then you should be able to say, Taylor, that top does not add together. So you keep them separate. And what do you think the answer is?
1x plus 12x.
1 plus 12x. Don't just add an x to that 1. There's no x up there. 1 plus 12x over, what's the denominator? 3x. And there you go. That's the answer. Now, some kids would like to cancel off these x's right here. You cannot. Why not? Because this is part of an add problem. Okay? This is a really common thing. If you see like, here, 1 plus x over x, tons of kids think you can cancel that. Why can't you? Because it's part of an add problem. Okay? So that cannot get canceled. If it was 2 times x over x, then that could cancel. And the x's would cancel and it'd just be 2. Why can you cancel on those? Because it's part of a multiply. All right. So that's adding. Subtracting would be exactly like adding. Multiplying and dividing are much easier. Multiplying is super easy. Would everybody please multiply that out and tell me what you get? Okay, did you get 8 over 3x? Because that's what you should have had. That's all you got to do. You don't need a common denominator. You are just multiplying across the top and the bottom. So easy. Sometimes kids think it can't be that easy. I must be doing it wrong. That's that easy. How about dividing? It is so simple as long as you know that only one of them flips. A ton of people will think that you flip them both over and then you multiply. Nope. So Studer, what do you think? What times what?
It's going to be 2 times 2 and 3 times 1.
Yep. I'm just going to say 2/3 times what?
2.
Yep. And then that's 2/1, but you can just say 2 if you want. I like to have fractions. Always if I have a fraction here, I put a fraction here, because then it's just easier. So then I get 4/3. Raise your hand if you had that one right. Okay, cool. How about dividing fractions when there's variables? 2x over 3 divided by x over 7. Two x over 3 divided by x over 7. Give that one a shot. Connor, do you flip them both over?
Nope.
What do you do?
You flip the last one.
So then it's 2x over 3, what?
7 over x.
And what's in between them?
Time.
Yes. Final answer?
14x over 3x.
Can you cancel on that kind? Yes, because it's a multiply problem. So final answer?
14.
Yep. There you go. Okay. Do they get harder? For sure. Usually because you can factor them. So imagine this one. X squared plus 3x minus 4 over x squared minus 16. I have a saying, if you can factor it, you should. Because you'll notice then that stuff will cancel. Pause for a second. X plus 4, x minus 1. Yup. How do I know he's right? Because I just, in my head, quick, I go this, and I make sure that it equals that. Okay, so 4x and negative 1x makes 3x. Nice job. And how about the other one?
X plus 4, x minus 4.
Yup. This is one of those pattern ones. X and x will make the x squared, of course. 4 and 4 make the 16, and it's negative. And then when you do outside inside, they cancel, so there's no middle term. So yay. Now, why do you think I set it up that way? I purposely made the problem this way. Marcella, do you know what's going to happen next?
Cancel.
Yes, what cancels?
X minus 4 and x plus 4.
Close.
X plus 4 and x plus 4.
Yes, the ones that are exactly the same. Those two. Those cancel, so there's your answer. X minus 1 over x minus 4. So let's just back that off one more time and make sure you got how that happened. Because I need all of you to be able to do this. Okay, this just factored into this. And this factored into that. All right, so I'm going to give you one just like it. Everybody try this. X squared minus 25. Right away you should be thinking, oh, I know how to factor that. And then x squared plus 4x minus 5. Telling you factoring is such a big deal that in my honors pre-calc class today, in one of my hours, everybody in the room was stuck, and it was because they didn't notice that the thing could factor. Another hour, I went through and looked at the assignment, and out of the 3 hard problems, 2 out of the 3, you had to factor it to solve it, okay? You guys are eventually headed towards pre-calc. Some of you are going to take it next year. Some of you will take it the year after that. And some of you won't take it till you get to college. But for most of you, you need to get through a pre-calc. Most college programs want you to get through pre-calc, at least. You don't have to always do calculus in college, but usually they want you to get through pre-calc. So this will happen. And it has to do with factoring. It's just usually more complicated factoring than this. But x plus 5, x minus 5. And you can reverse those. You know, put the minus first if you want. Doesn't matter. And then x and minus, I feel like it should be plus the 5. and minus the 1. Now, that's the part where a lot of people aren't sure. So how do I check? What I call the smiley face of factoring. See how that makes 2 smiley faces? And the outside one makes negative 1x. The inside one makes 5x. If I put them together, I get 4x. And that's what I wanted, so yay. And then this cancels this, and my answer is x minus 5 over x minus 1. How many of you feel like you could do that? Like if I gave you one and offered you $100, how many of you guys would collect? You got this kind. Okay, good. Seems like most of you. All right. Then here's another kind where you can factor it, but you want to get a common denominator, so it's going to be more complicated. 2x plus 8, sorry. Do you get that there are 2 factors out of that? A lot of people don't ever see that 2 comes out of that. Over x minus 4. Write this one down if you haven't already. Times by 2x minus 8 over 1. So, some kid would look at this and say, I need a common denominator, and so I'm going to do blah, blah, blah. Nope. How come you don't need a common denominator? Yes? Because it's a multiply. Yeah, and multiply, you don't need a common denominator. So, then some kids are just going to brute force multiply across the top, and they'll get like 4 parts to this, and no. That's wrong too. Why can't you just multiply across the top and the bottom? Because if you can factor it, you should. Would everybody please factor the thing I put in parentheses? Get it all factored, and then you'll see something that cancels. So Taylor, what factors out of 2x plus 8? What's in both parts of that, Taylor?
2x.
There isn't an x in both parts.
2.
2. Just the 2. So that factors to 2 parentheses. And then you got to think, what do I want here and here? You got this, or I'm going to call on somebody else? All right. You can do this. It's not that hard, but I'll get you off the hot seat. Truckee, 2 times what and 2 times what would give us our 2x plus 8?
X plus 4.
Yep. And then let's factor this one. For Truckee, what goes into both of those?
2.
So I put the two out there, and then what do I got?
X minus 4.
Yep. Now, I'm going to rewrite my problems because it got messy. 2x plus 4 over x minus 4 times 2x minus 4. Now, I know some kids would have tried to just multiply out. Even right here, some kids would. But what should you do before you multiply it out? Come on, you can do this. I think you see it. You canceled them before. What cancels?
The 2 things.
Yep, the 2 things.
The x minus 4.
Yeah, they're gone. So they're gone. They canceled. Because there's one on the top, one on the bottom. If you're like, how is that on top? I can almost put it over 1, right? That one was on the top. And now all that's left is this, but I'm still afraid some of you won't know what to do. Please give me what the final answer is. I get it. It's not incredibly easy. You can't just copy the top down. You got to actually multiply it. Have you heard of this before? We can do this the hard way, or we can do it the easy way. I think my dad said that to me once. So this is the easy way. You just take the 2 times the other 2, and then it's 4 times x plus 4. That's the easy way. Just multiply these 2 together. Now, if that seems wrong, it's because you want to multiply this out and get 2x plus 8, and then you times it all by 2. And guess what you'd end up with? 4x plus 16. Both of them are right, but one of them is way easier. Okay, so could you have multiplied this all out and then times it by 2? Yeah, you'd have gotten 4x plus 16. See how my answer is a little better than 4x plus 16? Because my answer's factored. Okay, so let's see if you could handle one. Imagine it's the test, and it goes like this. X squared plus 6x minus 7 over x plus 4 times 2x minus 14 on the bottom and 2 on the top. Could you just multiply it all out? Yeah, but you'd have so much reducing to do that it would be a really bad idea. So my advice is if we can factor it, you should. This factors and this factors. And once those things get factored, your life gets easy. Eddie, have you got the problem copied down yet? I'll take that as a no.
What?
I was asking if you had the problem copied down yet. Do you? Okay, I think you're working on that, which is good. Because there's no way you're just going to do this all in your head. Okay, so now let's factor this puppy. And it's all over x plus 4. And I might be thinking there'd be an x plus 4 in it, but there's not. Times, top of this one's just a 2, and that cannot be factored. So then I just have this part. Any of you feel like you got it? Raise your hand if you feel like you've got this. All right. Only one confident person in the room. Would you tell me what you think? Just do one of the two, not both. Factor one of them. Yes.
X plus 7, x minus 1.
X plus 7, x minus 1. If I wanted to check him, it's kind of like the upside down smiley face. I'm going to check that. And it does equal 6x. Yay, he factored it right. Parker, I'm going to ask you to do the red one. This factors, and some people get stuck on this kind. Can you do it?
Yeah, I had 2 on the outside.
Yep.
And then I had x minus 7.
You are so right. Now that it's all factored, what cancels? Taylor, what cancels? See anything where there's something on the top and something on the bottom that are the same? I thought these were going to cancel too, but there's something slightly different about them. Do you get one's plus and one's minus? You cannot cancel that kind. Yes?
2.
Just the 2's. So then, what's left is you can leave these factored. Don't do the work of multiplying it all out. And I get why you might think so, but no, you don't have to. You can leave them factored because you remember my favorite saying, if you can factor it, you should. You do not have to multiply that all the way out. Because factoring is like the higher form of life. That's it. We're done. Could you have multiplied it all the way out? I wouldn't have marked it wrong. But it would have been a big waste of time. Why is factored better? Because then I can see if stuff will cancel or not. If it's all multiplied out, you can't tell if you're missing something that would cancel. But the way it is now, it's all factored. I can tell there's nothing that's exactly the same, so I can't cancel anything, so I can be done. All right. I hope your brain feels a little warmed up. So that's kind of where we left off before you took 10 or 11 days to just relax, which I'm really happy you got a chance to do. But now there's a new thing. There's a new thing in town. Y equals 1 over x is a new parent function. You know when I told you y equals x squared and I showed you it was this parabola and we ended up using it over and over and over again? You just kind of wanted to memorize that a parabola looked like that. Remember that? Well, this is one of those you just got to remember what it looks like. 1 over x. This is the weird one. It's a graph that goes like this and like that. And it never will touch here or here. So we put these dotted lines on it that are called asymptotes. All right, I want to show you the easy way in case you forget that that's how it looks. Because some of you are. You're going to be like, oh, what was that one graph we had to memorize? Forgot what it looked like. You make an XY chart. And all graphs, you can do this. You stick in any numbers you want. 0 would be, well, it's good to know. When you stick in a 0, 1 over 0 doesn't exist. That makes an asymptote. Because 1 over 0 doesn't exist. At x is 0, you have an asymptote. Okay. Next, you can put in like a 1. And if I put a 1 in, that's the next simplest number to put in. I put a 1 right here then. So it's 1 over 1. Y equals 1 over 1. Y equals 1. So 1 comma 1 is on my graph. It's right there. And if you kept on putting in numbers, you'd put in 2 and you get 1 over 2, which is 1/2. 3, you'd get 1/3. And what you're getting is all these points that get closer and closer and closer to 0. Same thing happens if you put in like -1. Then the equation was y equals 1 over x. So it's y equals 1 over -1. So -1 goes with -1. Also a perfect point, but those are the only two perfect points. 1 comma 1 and -1 comma -1. Every other point is weird fractions. So yeah, you can get a lot of other points, but none of them are perfect like that are right on what are called a lattice point. Just -1, 1, or -1, -1, and 1, 1. So I hope that was enough so that if you see this on a test, you go, oh yeah, that's that one graph that goes like this. Now, a lot of kids remember that it's kind of got two parts. And then they might do this by accident and go, I think it's this and this, for instance. That couldn't exist. Do you remember the thing called the vertical line test? That wouldn't pass the vertical line test. So it can't be that way. There is a different function that looks like this. That's 1 over x squared. But that's in pre-calc. You don't have to know that one. Okay, so it's not that. Just try to remember. It's that and that. And then there's an asymptote here and here. Now, it feels like that's the end of the class, but that's the halfway mark in the class. So, all right. So here's the last thing that gets more complicated. What if I move it around? What if I say add 2 here? And it's inside in the fraction. 1 over x plus 2. That moves it 2 to the... Anybody want to take a guess? Does that feel like 2 to the left or to the right? What do you think? It is 2 to the left. Very good. What if I put a plus 7 here? That does not mean 7 to the right. That means 7 what? Up. That's up. That's left. What if they were negative? Well, then they'd be down and right. Okay, so let's look at one. Y equals 1 over x minus 8. That's this parent graph, which would have had asymptotes at 0 for each. This always is confusing. It's the y-axis, so it's x equals 0. The one that runs, I'll make it red. The one that runs vertically here, that's x equals 0. The other one, this one here, that's y equals 0 because it's on the x-axis. The x-axis is where y equals 0, and the y-axis is where x equals 0. Kind of like opposite day. Okay, but if I do this, would you agree the whole thing is going to shift right? 8. then the up and down asymptote is going to move to the right 8 spots. But the across asymptote, it isn't even going to move. So x equals 8 becomes the asymptote. Ooh, look at that. It's whatever makes the bottom 0. Whatever makes the bottom 0 is the asymptote. Another way to just think of it is it just got moved 8 to the right. And if you know it started at 0, your asymptote moved 8 to the right. So then my whole graph, here's my final answer. My whole graph, my asymptotes are here and here. Oops. And then it looks like that and that. Is that good enough for a test? Nope, you'd need one more thing. Perfect points there and there. And this graph was again y equals 1 over x minus 8. And my perfect points would have been at 7 and 9. And I want you to think about why. Because if I stick in 7, I get 1 over 7 minus 8, which is 7 went in, and I got -1. Ooh, that's this one. And I stuck in a 9. And I got 1 over 9 minus 8, 1 over 1, which is 1. That's this spot. 9 comma 1. This spot was 7 comma -1. So on a test, you are required to give the asymptotes, the dotted lines, and this is an x equals 8 line, and this is like the y-axis, you know, because the y-axis runs like this. So it's x equals 8. And this is like the x-axis here, so it's y equals 0. That was a lot. I know, it was a lot. But now, theoretically, you know everything you need to know before our test. So I try to pre-teach it like that, and for some kids, that's enough. Like, you're just practicing from now on. For others, I just did too much and your brain couldn't hold it. Well, I'll be teaching it again tomorrow. Okay? So let's look at your homework, which is practice. You'd have to, for instance, graph that. Imagine that you had to graph this. I'd start with this. Say it's kind of like that. And then I'd go, ooh, it moved 4 to the what? Is that left 4 or right 4? Left 4. Then everything gets moved left 4. So this asymptote that was here is going to go 4 to the left. So I got to move all of this stuff over. And my best hint is move the asymptotes first. So 4 to the left. And this one never moved. And then I just make my lines like this. And this. And the last thing I can talk about is XY chart can always save the day. If you want to just stick in numbers, stick in 0, see what you get. I got 1/4. Graph it. I stick in 1. I got 1 over 1 plus 4 is 1/5. And I start realizing, oh, if I keep putting in numbers like that, it's just going to keep getting smaller and smaller, so maybe I'll stop doing that. Maybe I should put in like -4, and then I'll realize that's the asymptote. Because you'd have a -4 here would give you a 0 on the bottom, and you can't have 0 on the bottom. That makes the asymptote. So you can always make an XY chart to get your points. A -4 would have given you an asymptote. This one's at x equals 0. No, wait. That's the x-axis. It's at y equals 0. This one's at x equals -4. 2 perfect points are right there and right there. Everything else is a weird fraction answer. And let's get to your homework. I'm going to pause for a second while we pull up the homework. So we found the worksheet. We are going to skip 2, 3, 6, and 9. Why? Well, that cuts your assignment way down. Makes it much more doable. All right, let's do the first one together. Question number 1. Marcella, can you read me the question?
Um,
What am I supposed to graph on that one?
the tail graph.
Okay, and it's
Sorry, that's not what you're asking for. 1 over x.
1 over x, I think was the key. Yes. Okay, so now I got to stick in some points on my graph. I can pick anything I want. I pick 0, but then I'm smart enough to go, you can't have a 0 there, so that's the asymptote. At x is 0, you get an asymptote. You can abbreviate that with ASYM. Nobody needs you to know exactly how to spell asymptote. Okay. Truckee, give me another number to stick in. I get to put anything I want in there, so pick. -2, he says. Then I'm going to put a -2 right there. And y equals what? -1/2. That's one of the points on the graph. So if I wanted to graph it just by kind of knowing how it looks, I'd go like this. And this, because I know that's how they look. And then this one hasn't been shifted at all, so it's at a perfect. If I put in 1, I'd get 1. Look what happens. If I put in 1 right here, for x is 1, I get y equals 1 over 1 is 1. 1, 1 is a thing. That one's another important spot. -1, -1. When you put in -1, you get -1. There's your graph. Here's your table. And the last thing you got to do is put asymptotes in. Remember, if it's the x-axis, then y equals 0. And remember, if it's the y-axis, then x equals 0. Those are the asymptotes. They're going to for sure ask you for those on the test. All right. That's problem 1. I said you could skip 2 and 3. So now I go to problem 4. And then eventually you'll skip 6 and 9, but number 4. Eddie, read me number 4.
F of x equals -4 over x.
-4 over x?
Yep.
Just checking if I heard that right. Okay. Oh, I'm glad we talked about this one, because this one's different than all the other ones. If I had to graph this thing, I would think, well, it looks to me like this has a negative in it, which makes it flip. So my normal graph would have looked like this. Do you get negatives, make them flip over? And so it'd be like this blue one. That's generally what it looks like, is the blue one. Because I made it flip. Negative on the outside is a vertical on the outside, so it's a vertical flip. So this black thing became this blue one, and this black one here became this blue one there. So now these are gone. And when there's a negative in front, it looks like that. It's flipped. And then if I had to get exact points, definitely use the XY chart. Now you stick in anything you want. If you put in 0 though, you'll realize can't have a 0 on the bottom, must be an asymptote at x equals 0. Then you can stick in like -4 would be nice. You know why? Because -4 divided by -4 gives you 1. That'd be a good point. How about if I put in -3? I put in a -3 right here. It's -4 over -3 makes +4/3. That's like 1 1/3. That's a point. Is there any other nice point I could put in? Yes.
+4.
You are correct, sir. +4. When you stick a +4 in here, you have -4 over 4, which is -1. Very nice. We found the 2 perfect points. And we know there's asymptotes. There's an asymptote at x equals 0. Another asymptote at y equals 0. You can see it. Okay, that's a lot, but at least we're partway done with the second problem. There's only a few left. That's your homework. And now you've reviewed everything, and we've taught you new stuff. Tomorrow, a little more on the new stuff, and a review, and then the test Friday. Or if my colleagues talk me into it, We might put the test off until later than that. So, I know I covered a lot of stuff. This is not a democracy, but I'm curious. How many of you would be kind of terrified if the test was Friday? There's only a few people. All right. Good, because it might be Friday. But we'll see. All right, just work on your homework. Please feel free to come up and ask me questions. I want to help you, but you got to ask. And that's all I got for the video for today.